Comprehensive rules for distance, rate, and time, or bodies in motion. There are many approaches to distance, rate, and time. However, many are applications for solving a particular problem. What we are going to try to do in this video is to present a comprehensive method for solving distance, rate, and time. As you probably know, distance equals rate times time. Now there's simple DRT, which is basically one body in motion. To solve for D equals RT, let's say that we know that the distance is 200. That could be 200 miles, 200 kilometers, it doesn't matter. And let's say the time period is 4 hours. To solve, we are going to divide both sides by 4. That will leave us with rate equals 200 divided by 4, which is 50. Or in this case, 50 miles per hour. Complex DRT is much more complicated because it involves two bodies in motion. To solve for complex DRT, there are 4 basic rules. Rule number 1. The distance of the first body equals the rate of the first body times the time of the first body. The distance of the second body equals the rate of the second body times the time of the second body. Do not use the variable x. We will not be solving for x and we will not be solving for y. We are solving for d, r, or t. In other words, we have 6 variables. There are 3 variables for each body. Rule number 2. Does d1 plus d2 equal the total distance? Or does t1 plus t2 equal the total time? If so, let's say that we know that the total distance is 200 miles. Therefore, d1 plus d2 equals 200 miles. Then subtract d2 from both sides of the equation. And that will leave us with d1 equals 200 miles minus d2. And d2 will equal d2. We did not do the same thing for d2. If you do, then you have not eliminated a variable. One of the things we're trying to do with this process is eliminate the variables one by one until we have it down to one variable. Rule number 3. If you know 2 of the variables for body 1 or body 2, then you can solve for the third variable. Rule number 4. Do both bodies start at the same place and finish at the same place? If so, d1 equals d2. Do both bodies start at the same time and finish at the same time? If so, t1 equals t2. Or, let me give you an example where that's not true. Let's say Jim and Bob are walking north. Bob starts 2 hours later than Jim. How long will it take Bob to come within 6 miles of Jim? Jim will represent body number 1 and distance number 1, and d1 equals d1. Bob will represent distance number 2, and as you can see, he is walking 6 less miles than Jim. Therefore, his distance equals Jim's distance minus 6. And Jim's time is obviously t1, therefore t1 equals t1. Bob's time is t2, and again he is walking 2 less hours than Jim. Therefore, his time is going to be Jim's time, t1, minus 2. And now for our problem. A jet is flying from Smith Airport to Jones Airport at 600 miles per hour. Another jet is flying from Jones Airport to Smith Airport at 500 miles per hour. It is 880 miles from Smith to Jones airports. If both jets take off at the same time, when will they pass each other and how far will each jet travel? Now we're going to set up all the variables on the left-hand side of the page in this order. D1, R1, T1, and the second group will be D2, R2, T2. We have 6 variables to solve for. It is impossible to solve for any equation with one answer until you have eliminated all the variables down to 1. Therefore, we are going to be eliminating the variables one by one. The first thing we do is read the problem. What variables are answered in the problem itself? R1 equals 600 miles per hour. R2 equals 500 miles per hour. And I'm going to draw a little map to visualize the problem better. As you can see, I have Smith Airport on the left-hand side, Jones Airport on the right-hand side. The distance between the two airports is 880 miles. And most importantly, the jets are flying toward each other. Now for this problem, we're going to use rule number 2, which shows that distance 1 plus distance 2 equals the total distance. According to the problem, the total distance is 880 miles. So in accordance with rule number 2, we are going to subtract the distance of the second body, and distance 1 will equal 880 minus d2. Again, do not do both. d2 will equal d2. It will not equal 880 minus d1. So now we've solved for two more variables. d1 equals 880 minus d2, and d2 equals d2. According to Rule 2, since the times are the same, t1 equals t2 and t2 equals t2. Again, do not make it t1 equals t2 and t2 equals t1, or you will not have eliminated a variable. What we've just done is eliminated one more variable. Now let's go back and look at the problem. We know that t1 equals t2 because they both took off at the same time. And the problem is completed at the same time because once they pass each other, the time is completed for both airplanes. They start at the same time and they pass at the same time. That is a very common problem for bodies in motion. Planes that pass each other or planes that intercept each other are usually planes that start at the same time, and when they intercept each other, they do finish at the same time. Now we have filled in information for all of our variables. So let's go back to the simplicity of distance equals rate times time. Obviously, the formula for the first body in motion is d1 equals r1 times t1. And the formula for the second body in motion will be d2 equals r2 times t2. Now if we go back to our chart, we'll see that d2 equals d2. Our chart says that r2 equals 500 and t2 equals t2. Therefore, when we say that d2 equals r2 times t2, what we have filled in for our variables is d2 equals 500 times t2. For our first body in motion, we agreed that d1 equals 880 minus d2. If you look at our chart, that's what we filled in for d1. Our rate is 600, and our time was t2. Remember that t1 is the same as t2. And our formula now for the second body is d2 equals 500 times t2. Now let's take these two formulas and we're going to substitute in the second formula for the first formula. For the second formula, we know that d2 equals 500 t2. Therefore, we're going to insert 500 t2 into the first formula. Now let's look at the first formula again. And it is going to become 880 minus 500 t2. Because that's what d2 equals, 500 t2. And that will equal 600 t2. Do you notice what we've done? We have finally gotten 6 variables down to one variable, which is t2. We now have a formula with only one variable in it. So let's add 500 t2 to both sides of the equal sign. And we'll have 880 equals 1100 t2. Let's get t2 alone by dividing 1100 from both sides of the equation. Remember, the equal sign means whatever we do to the left-hand side, we have to do to the right-hand side. Whatever we do to the right-hand side, we have to do to the left-hand side. We are dividing both sides by 1100. And t2 will equal 0.8. Or, if you would like to know how many minutes that is, just multiply 0.8 times 60. And that equals 48. So t2 equals 48 minutes. Now let's go back to our list of variables. We agreed that t2 equals 0.8 hours. Therefore, T1 equals 0.8 hours. Now to solve for the rest of our variables, we go back to our basic formula, distance equals rate times time. The formula for the first body in motion is D1 equals R1 times T1. And as we know, D1 equals 600 times T1. And since T1 equals 0.8, D1 equals 600 times 0.8. D1 equals 480. That is to say, 480 miles. And for the second body in motion, D2 equals R2 times T2. The distance for the second body equals 500 times T2. T2 equals 0.8, so the distance for the second body equals 500 times 0.8, or 400 miles. So we've solved for two more variables. Let's insert them into our chart. Distance 1 equals 480 miles. Distance 2 equals 400 miles. Those are the 6 answers to the 6 variables. Now when you complete your problem, go back and read the question again. If both jets take off at the same time, when will they pass each other? The answer to that question is 0.8 hours. And how far will each jet travel? We have also answered that. 480 miles for the first jet, 400 miles for the second jet. Now let's do a quick check. Distance 1 plus distance 2 equals the total distance, which we knew from the beginning was 880 miles. Distance 1 is 480 miles. Distance 2 equals 400 miles. 480 plus 400 equals 880. Therefore, our check is correct. And that completes our problem. Thank you for watching.